recycle.
Well, let's take some of your questions. I'm noting that none of them said it was hard to get to market or reaching the customer, so that's kind of interesting. Your questions.
Well, I am impressed. You are the good guys, and I want to know where the bad guys are, but we'll talk about that later. But let me ask you this, because I work on at the end of the pipe, not at the front end. So when you designed your product, did you consider what was going to happen after I used it over and over and over and over and over again, but I was finally done, or was finally broken, where it was going to end up? And secondly, did you ever consider taking that product back and reincorporate it back into a new product?
Well, I can answer that. We did spend a lot of time thinking about that, and reuse was the forefront. Reuse was the forefront of what we wanted the product to be designed for. But when it did end, where would it go, and what material was it made out of? That's why we chose PET. So that was something I didn't cover. That this bottle was all made out of PET, and so were the pods, because the recycling stream is what it is. It's extremely inefficient. It's not going to change anytime soon as much as we want it to. Municipalities don't have the money. But in terms of someone shipping something back to us, it's not nearly as beneficial as making sure it's a clear plastic with no color in it. That's another big thing. That means it can actually go back into the waste stream and have a chance to be a bottle again. Now, would I love to make this out of a plant material? Of course, but we had to even prove that you could ultrasonically weld plastic to itself. That was another thing that was very difficult in PET that they said they couldn't do. So there's steps that we can get to, but reuse is something that I think is so important that needs to be designed into the front end of problems, so we don't have to tackle the back end with as much vigor as we're trying to do now. We can actually get some leverage out of it. So.
Yeah, I think you can make a huge difference with waste by attacking from the front end. And how I thought about our bottles was, I did the research for sourcing and the materials, and the glass it can be recycled. It gets broken, you put it in the recycling bin. The silicone can be sent back to us. We have that on our website where you can send back to us, and it can be reground into playground mats and to barn mats, or like cow mats where they can lay down when it's cold. So that's what they get reground into. And then we try to be very minimal with the plastics. We just have our lid is made out of polypropylene, and that is recyclable. So I know there are some other products on the market. I think a new one has come out where they try to spray like a plastic coating on glass, but actually you can't really recycle that after something's been sprayed on glass. So we've been trying to be very, very careful with our packaging and with our product as far as what the end use is as well.
I'll just add one more thing. The irony of all of this is when I had my clothing company, the reason I discovered bioplastics was because I thought the hang tag, which is the front end waste, was so absurd. And if you look at some of the designer companies, they're making them out of metal, which I guess is better than plastic, but it's just absurd because there's absolutely no value. This is like a race to the bottom for packaging. It's the same reason why everything shipped from Asia now has to be packaged in plastic. And a lot of you probably don't know that your t-shirts from Gap come in plastic bags and they take them out before they put them on the shelves. So there are some international policy areas that we as a community should focus on that are very logical and would just reduce consumption. But our products have all been, so that I actually found the biodegradable plastic because of the sticker that I replaced my hang tag with. And then I discovered first generation. And in terms of the topic of today's conversation, this I just wanted to show you, and whoever has the little black one, I need to get it back. But these products are very durable. I mean, they're like, we almost think 4 of these cups would support a car. So they incorporate structural grade, concrete style strength with the heat resistance of a ceramic plus the sustainability factor of a plant plastic. And afterwards, if you'd like to understand how it's still possible for it to biodegrade, I'll spend the 25 minutes explaining the chemistry to you, but I can explain that as well. But a lot of it just has to do with the way that the crystals are made within the product. This product is what opened up the door to the secondary product, which is EcoPEC, which is the product that looks like recombinant wood. And we own all the patents on all of these material processes, but fundamentally they're designed to be durable grade. So we want you to use this cup for years and years and years and years and years, as long as you can, knowing that it doesn't leach and that it's safe and that it will last, with the idea that if it is, at the end of life cycle, hopefully I will, as I am, be working to remediate all of our cradle-to-cradle issues, including the sustainable management of biomass and the end-of-life cycle for our products. But they are closed-loop, one-to-one recyclable. So this cup can become another cup, and this cup can become, if you add clay, this cup. And so there's an upcycling and a downcycling and a recycling component to all of our materials.
I just want to make a comment. I'm a doctorate student of polymer science and technology, and PET is a 100% recyclable polymer. Even in a poor country like Brazil, we have several plants that closes its life cycle. A bottle becomes another bottle. We don't do this in our country because our legislation does not allow, but in Europe and America, Coca-Cola PET bottle becomes another Coca-Cola PET bottle. I just want to give you this information. It's not difficult. It's perfectly and economically viable to recycle PET.
It is, if you can collect every single bottle that is out there. So PET does have the promise of recycling 100%, but I don't know of any country that has 100% PET content bottle. The PET content is usually 10%, 15 at most, and the rest of it is virgin plastic.
This is an issue that has been heavily debated in the recycling community. Though it is chemically possible to do this, there are no examples of it currently on Earth. So we have to kind of question whether or not we talk about this as a true recycle stream, or it's definitely downcyclable. With the addition of virgin petroleum, we can reutilize this material. A lot of it has to do with color. It's shocking how little minute changes in chemistry or color or additives kill the ability to recycle something. So
let's take one more question.
Okay, I have a question. I have one comment and a question. With regards to recycling plastic bottles, I think nobody's talking about the caps, and they're made out of a different plastic, and as far as I know, they are not recycled in any way. I just want to mention that. They are? Okay, we can talk about it later. And then a question for Jeff. I'm just curious if you're able with Pylantis to make it as well transparent, and if you are you using phthalates or bisphenol, or what kind of chemical would you be adding to get the transparency? I'm curious.
Yeah, we're fundamentally opposed to hydrocarbon-based additives. So I've spent most of the last 12 months identifying first-generation naturally derived additives that in many cases can achieve similar, or in some cases more unique properties. So this is an example, and not to bring up the color issue, but this is an example of the first generation of plant-based or flower-based master batch polymer. So this is actually a polymer made from marigolds. So we have identified, and I can't officially make this announcement because all of the science isn't done, but from our goal, and I think we'll have achieved it within the next 24 months, is to create the first line. And I guess based on the doctor's comment, I can't say natural, but non-petroleum-based products, which means we can achieve all of those properties. Currently with glass, we have heat resistance, which is far superior to a traditional PLA because we have a different process. But to achieve something like a glass, most likely will be our next generation, where we substitute, for example, the clay portion with glass. So we could take a recycled glass stream. The issue is not that we can't do it because we can make that product today. The issue is the clarity. So when you're dealing with going from a crystal clear product like a PET, a little bit of lack of clarity causes the end user or the Fortune 100s to be a little bit, what is this unbreakable plant glass? So there's a few, obviously we're sort of at the very beginning. And what's so unique about this mechanical process technology, the Plantic difference, is that it allows for any type of incorporation of materials. So depending on what you put in, the material qualities change. And some of our plant-based materials are non-biodegradable. They're, for example, might be good for printing a engine block in a Mustang that weighs 9% of the current steel and is not biodegradable because we don't want it to be biodegradable. So there's a vast variety of material processes, and we sort of can obviously utilize traditional additives. We choose not to unless our consumers demand, in this case B2B consumers, demand those additives from either a regulatory compliance or issues with the flame retardants. But we're also looking to incorporate a variety of other natural matter that may achieve similar results using, for example, who knows if coconut shells are more flame retardant than would. And maybe if we'd used coconut shells for that portion of that particular product, we'd achieve higher flame retardance. So we're decentralizing the chemistry.
I want to say one thing, because we talk about materials. I mean, if we made this out of coconut shells, a 26-ounce bottle, and then threw it in the ground, and 90 days later it went away, the fact is we're still shipping around water everywhere. This product, if it was a cleaner or a fertilizer, it's 95% water. That's bulk and weight. That is mass. That's the enemy of sustainability as well. We've got to talk about that. That weight has a cost in fuel. So we've got to start thinking about what it is we're buying. What is it made out of? You know, we have a technology. It's called water pipes that go into our homes. We don't have to add it at a factory. So we don't. I go around and talk to sustainability people all the time, and no one's talking about all the water we're moving all around. 7 billion pounds of bottled water. We all talk about it, vilify it. We use 7 billion pounds of water in our personal care and household cleaning products alone. That's just in the U.S. Not talking about the beverages, all of this packaging for single-use transporting water. But we spend all of our time on the material. I mean, we really need to think about functionality at the front end. I'll end there.
I would like to end the panel here. Thank all the panelists for their time and attention. And I wanted you all to know Plastic Pollution Coalition has a stainless steel straw for all of you. We'll put them outside on the table. So before you go for cocktails, make sure you take one and never, ever again use a plastic straw. Thank you.